In 2001, a professional underwater survey team hired by the Cuban government was scanning the ocean floor near the western tip of Cuba. Their job was simple: find Spanish shipwrecks, map what was down there, move on. They were not looking for mysteries. They were not trying to make headlines. They were oceanographers with government contracts, professional sonar equipment, and decades of combined field experience. And then, at 700 meters below the surface, something appeared on the screen that none of them had a category for. Not a shipwreck, not a reef, not any geological formation in their databases. Straight lines, right angles, repeating patterns. Massive rectangular structures, some of them appearing larger than the research vessel floating above them, arranged across the seafloor in a way that nobody on that ship could immediately explain. They ran the scan 5 more times, from 5 different directions, with 5 different equipment settings. Same result every time. Whatever was down there, and it was real. What it was is a question that has never been fully answered. The mission and the team. The expedition was led by Paulina Zelitsky, a marine engineer with advanced digital communications, a company that had spent years doing legitimate government-contracted underwater survey work. This was not a TV crew chasing legends. This was not a YouTube channel with a GoPro. The team had a research vessel, high-level sidescan sonar equipment, and a formal contract with the Cuban government to map the seabed off the island's western coast. The initial goal was historically grounded. The waters around Cuba had claimed dozens of Spanish galleons over the centuries, ships carrying gold, silver, and colonial-era cargo that went down during storms or conflicts and were never recovered. The team's job was to locate whatever remained. For the first several days, the mission delivered exactly what everyone expected. Irregular seafloor, mud deposits, scattered rock formations. The kind of data that experienced surveyors can read in seconds. Natural, unremarkable, routine. Then the routine ended. A section of the sonar return showed something that didn't match any natural pattern the operators had seen before. They adjusted the equipment, recalibrated, reran the scan. The same image came back. Lines that were too straight. Spacing that was too consistent. Shadows, and this is the critical detail, shadows that indicated elevation. Something was standing above the seafloor with clear edges in a location where nothing of that kind was supposed to exist. What sonar actually tells you? Before going deeper, it's worth understanding exactly what the team was looking at, because the technology matters. Sidescan sonar works by emitting sound waves horizontally across the seafloor and reading what bounces back. Soft surfaces, mud, loose sediment, absorb the sound and return a darker signal. Hard surfaces, rock, dense material, reflect more strongly and return brighter. The result is not a photograph, it's an acoustic image. A map of hardness and elevation built from sound. And here's what experienced sonar operators know. Natural geological formations have a signature. They look irregular, organic. Edges wear and round over time. Patterns repeat loosely, not precisely. What was appearing on the screen off western Cuba did not have that signature. The shapes were showing consistent right-angle corners, parallel lines at near equal intervals, and most significantly, shadows. In sonar, a shadow only forms when an object is elevated above the surrounding surface and blocks the sound wave from reaching the area behind it. A flat rock layer doesn't cast a shadow. A buried object doesn't cast a shadow. Something has to be standing, raised with defined edges, for a shadow to form in sonar data. The structures below were casting shadows, which meant they had height, they had edges, and they covered a substantial area of seafloor. The team ran 5 passes over the same location, changing direction, speed, and frequency settings each time. The data was consistent across all 5, the ROV descent. At that point, the decision was made to send a remotely operated vehicle down. At 700 meters, you're operating under more than 70 atmospheres of pressure. Sunlight is completely absent. It hasn't touched those depths in the time since whatever is down there was placed there. If the ROV's cable snaps, or a seal fails, or a system shorts out, the vehicle stays on the floor. Permanently. So the team prepared carefully. Every connection checked, every seal inspected. Lights tested repeatedly because at that depth, artificial light was the only thing that existed. The ROV went down. At around 300 meters, the control room went quiet. The screen showed only darkness and the cone of the floodlights cutting forward. Then, at depth, the seafloor appeared. And the control room stayed quiet for a different reason. The structures that had appeared on sonar were there, large, flat surfaces, rectangular shapes, edges that were, and this is the word multiple crew members used independently, cut. Not worn, not eroded into roundness the way deep ocean rock normally looks. The shapes had corners that held. Some blocks appeared arranged in lines, some at consistent intervals. The ROV moved along them and they kept appearing. More surfaces, more edges, more of the same organizing principle that should not have been present at 700 meters below the surface of the Caribbean. One crew member moved close enough to the screen that her fingertips left marks on the glass. Nobody made a declaration. Nobody said what they were thinking. But every person in that room was thinking the same thing. The three natural explanations. The team did not immediately reach for dramatic conclusions. They were professionals. The first thing they did was work through the natural explanations. Ocean currents. Could decades of water movement have shaped rock into these patterns? The problem? Currents scatter material. They don't organize it. When water erodes rock, the debris spreads outward in irregular distributions. What the footage showed was the opposite. Consistent, repeating, directional, volcanic activity. Cooled lava can form striking geometric structures. Basalt columns, for example, naturally form hexagonal shapes as lava cools at uniform rates. But the structures in the footage didn't match volcanic formation signatures. The surfaces were too smooth, the edges were too clean, and the region's seafloor geology, predominantly limestone, doesn't produce the columnar fracturing that creates geometric volcanic forms. Tectonic stress. Geological jointing, where pressure fractures rock along consistent planes, can produce straight lines and right angles in stone. This was the strongest natural candidate, but jointing typically produces fractures along one or two axes. What the ROV footage appeared to show was three-dimensional arrangement. Blocks positioned relative to each other, not just cracked in place. None of the three explanations fully accounted for what the data showed. None of them were definitively eliminated either. That's the honest position the science was in, and in some ways it still is. The time problem. Here is the detail that makes this story genuinely difficult to resolve. If those structures were built, and that remains an if, then the question of when creates a problem that the current archaeological record cannot answer. The seafloor off western Cuba sits at approximately 700 meters depth. For land to have been at sea level in that location and later subsided to that depth would require either a geological event of significant scale or a timeline that predates any known human civilization by a substantial margin. The earliest recognized complex human societies, the kind capable of constructing large stone structures, appear in the historical record around 5,000 to 6,000 years ago. The geological timeline required for western Cuban seafloor to have been above sea level is measured in tens of thousands of years at minimum. That gap, between when humans could have built something and when the land would have been buildable, is the core problem. It doesn't definitively rule out a natural explanation. It also doesn't comfortably accommodate a human one. What it does is force a choice between two uncomfortable options. Either the structures are natural and we're still missing the geological mechanism that created them, or the human timeline we currently work with has a chapter we haven't found yet. Neither option is simple. Neither has been ruled out. Here's where the story has stayed for over 20 years. No rock samples were collected from the site. No isotope dating was conducted. No drilling was done to examine subsurface layers. And without those three things, science has no mechanism to move the question forward. Robert Ballard, the oceanographer who found the Titanic, has said it plainly: extraordinary claims require extraordinary evidence. Images and sonar patterns are not enough. The investigation that would actually answer the question hasn't happened, which is, in its own way, the strangest part of the story. A professional team, with government backing, using credible equipment, documented something they couldn't explain at 700 meters below the surface of the ocean. The footage exists. The data exists. The experts who reviewed it declined to call it either fully natural or fully explained. And then, essentially nothing. No funded follow-up. No international research coalition. No sample collection mission. The site sits there still, undisturbed, at depth in the dark. Whether it is geology being dramatic, which it sometimes is, or something that requires us to ask harder questions about what happened on this planet, before written history begins, we don't know. What we know is that the data was consistent, the team was credible, and the question has not been answered. That is either frustrating or fascinating, depending on how you look at it. For most people who've looked closely at this story, it tends to be both.